In 2025, a remarkable piece of news stirred excitement across the world. NASA confirmed that Voyager 1, humanity's most distant spacecraft, had once again begun sending usable information after months of scrambled signals. It was a reminder, not just of the challenges of maintaining contact across such unimaginable distances, but also of the extraordinary journey of the Voyager probes. Launched in the late 1970s, these two spacecraft have achieved what no mission before or since has matched. They rewrote our knowledge of the solar system, revealed worlds we had only glimpsed through telescopes, and then, as if that wasn't enough, became humanity's first messengers to the stars. The beginning of the grand tour of the 1970s were a golden age of exploration. For the first time in history, technology and celestial mechanics aligned to create an unprecedented opportunity. In 1977, NASA seized that chance. Voyager 2 launched first, on August 20th, followed by Voyager 1 on September 5th. Their timing was not accidental. Once every 176 years, the outer planets align in such a way that a spacecraft can use gravity assists, slingshot maneuvers around one planet to gain speed and redirect to the next. This rare alignment meant that, with careful navigation, one spacecraft could visit all four of the giant outer planets in a single journey. The Voyagers were designed as robotic explorers, each equipped with a suite of scientific instruments, cameras to capture the planets in unprecedented detail, spectrometers to analyze atmospheres, magnetometers to map invisible fields, and detectors to measure energetic particles streaming through space. To communicate across the vast void, they relied on the Deep Space Network, a trio of massive radio antennas in California, Spain, and Australia, which could pick up their faint whispers even as they slipped billions of kilometers away. Voyager 1. A tour of giants. Voyager 1's first target was Jupiter, the largest planet in our solar system. When it arrived in 1979, it shattered expectations. Jupiter was no longer just a swirling ball of clouds, it was a dynamic, violent world. Voyager revealed immense lightning storms crackling across its atmosphere and mapped the lethal radiation belts encircling the giant. But its greatest surprise came not from the planet itself, but from its moons. On Io, Voyager's cameras caught something astonishing. Erupting volcanoes, the first ever seen beyond Earth. This discovery alone transformed planetary science, proving that moons could be geologically active. Europa, another moon, showed a fractured icy crust that hinted at a hidden ocean beneath, a place that, decades later, would become a prime candidate in the search for life. In 1980, Voyager 1 swept past Saturn. It uncovered a planet of roaring high-speed winds and mysterious chemistry in its atmosphere. The probe revealed Saturn's iconic rings to be far more complex than imagined, composed of countless icy fragments, ripples, and structures shaped by unseen moons. It even spotted new moons nestled within the rings themselves. One of Saturn's most enduring mysteries, the giant hexagonal jet stream at its north pole, was first recorded by Voyager. After Saturn, Voyager 1's path carried it out of the plane of the solar system, setting it on course toward the stars. Voyager 2. The only visitor to all four giants. Voyager 2 took a slower, more winding journey, but what it accomplished was historic. It remains the only spacecraft ever to visit all four outer planets: Jupiter, Saturn, Uranus, and Neptune. At Jupiter, Voyager 2 captured sharper images of the Great Red Spot, revealing it as a massive storm system that has raged for centuries. It also studied Europa, Callisto, and Ganymede in greater detail, painting them as diverse, complex worlds. At Saturn, Voyager 2 enriched our knowledge of the rings, exposing intricate patterns and clumps that hinted at gravitational interactions with hidden moons. It also offered tantalizing evidence that Enceladus, a small icy moon, might be geologically active, a theory that decades later would be spectacularly confirmed when the Cassini mission discovered water-rich plumes erupting from its surface. Then came Uranus, a destination unlike any other. In January 1986, Voyager 2 became the first and only spacecraft to visit this distant ice giant. From nearly 3 billion kilometers away from the Sun, Uranus revealed itself as a pale blue-green sphere, its color owed to methane in its atmosphere. Yet what truly astonished scientists was its bizarre tilt. Unlike any other planet, Uranus is tipped on its side, rolling along its orbit with its poles pointing almost directly toward the Sun. This unusual orientation created seasons unlike anything we know. Each pole spends 42 years in continuous sunlight, followed by 42 years of darkness. Voyager 2's instruments showed that Uranus's magnetic field was equally strange. Instead of being centered and aligned with its axis like Earth's, it was tilted and offset, producing an asymmetric, lopsided magnetosphere. This meant that the interaction between Uranus's field and the solar wind was highly variable and unpredictable, a puzzle that scientists still study today. But Uranus had more secrets. Voyager 2 discovered faint, dark rings, far more subtle than those of Saturn but still encircling the planet in thin, ghostly bands. It also encountered a menagerie of moons, each with its own unique story. Among them, Miranda stood out as one of the strangest worlds in the solar system. Its surface looked as if it had been shattered and reassembled, with massive cliffs towering up to 20 kilometers high, the tallest known in the solar system, and patchwork terrain stitched together from different epochs. Some scientists suggested that Miranda may have once been torn apart by a collision and then reformed under gravity, leaving its surface scarred and mismatched. 3 years later, in August 1989, Voyager 2 continued its odyssey, reaching Neptune, the last planet of its grand tour. What it found there stunned astronomers. Neptune, though similar in size and composition to Uranus, proved to be far more dynamic. Voyager 2 measured winds roaring at speeds exceeding 2,000 kilometers per hour, the fastest ever recorded in the solar system, capable of circling Earth in less than 20 hours. These winds drove massive storms, including the Great Dark Spot, a colossal storm system nearly the size of Earth itself, reminiscent of Jupiter's Great Red Spot but with its own fierce and transient character. Neptune's atmosphere, with its rich blue hue caused by methane and perhaps other unknown absorbers, displayed high-altitude clouds casting shadows onto lower levels, giving the planet a striking, layered appearance. Voyager's cameras captured images that revealed Neptune not as a cold, distant sphere, but as a world alive with weather and energy. Then came Triton, Neptune's largest moon, and perhaps Voyager 2's most haunting discovery. Triton was unlike any moon ever encountered. Its surface was bitterly cold, coated in nitrogen ice, yet Voyager 2 observed geysers erupting, venting plumes of nitrogen gas mixed with dust several kilometers high into the thin atmosphere. This was the first direct evidence of active cryovolcanism, a form of volcanism powered not by molten rock but by volatile ices. Triton also orbited Neptune in the opposite direction of the planet's rotation, suggesting it was once a captured object, possibly a wandering body from the Kuiper belt. Its retrograde orbit and geologic activity made Triton a window into the solar system's turbulent past. These encounters with Uranus and Neptune were not just fleeting snapshots, they were revelations. In just a few days of flybys, Voyager 2 provided humanity with its only close-up look at these remote giants and their moons. Decades later, no other spacecraft has returned. To this day, the images and measurements sent back in the 1980s remain our most detailed glimpse of these worlds on the edge of the solar system. The legacy of these encounters is twofold. They not only transformed our understanding of the ice giants, but they also left us with unanswered questions. How do Uranus and Neptune generate their unusual magnetic fields? What drives Neptune's furious winds in such a frigid environment? Could Triton harbor an ocean beneath its frozen crust, making it a potential refuge for life? For now, those mysteries remain unsolved, preserved in the data of a single spacecraft that ventured farther than any before it. Voyager 2's brief visits turned distant points of light into real, dynamic worlds, and left us longing to return.